This video is on exponent rules or exponent properties. We're going to be focusing on what's called the power rule. The power rule is when you have a power, you raise a power to another power. Basically, you really see grouping symbols. You have parentheses, you have information inside the parentheses, and then you have an exponent outside of the parentheses as well. So we have a power raised to another power. What you do in this property is you write the base. You always just keep the base the same, but then you multiply the exponents. So the product rule, multiplication, told us to add. But now a power to a power is telling us to multiply. So I know it can get a little tricky with remembering all the different rules, but when you see a product, a multiplication, it kind of looks like a sideways plus sign. And the quotient rule was a division, which has a subtraction sign in it. Now, the power rule has parentheses, and we know that parentheses means multiplication. So we'll just multiply the exponents. So this example, the general rule, has parentheses, x to the m, close parentheses, raised to the n power. There's only one base in the problem, so we keep the base the same. We just write it out as x. Then we multiply the exponents. We have an m and we have an n. So we will do m times n, which is mn. So our answer simplified would be x raised to the mn. So let's do this with an example that's not already done for us. We have parentheses x cubed, close parentheses, raised to the second power. In this problem, we only have one base. That means we're going to write the base, just like it says, write the base. We have an information on the inside of the parentheses, and then we have an exponent on the outside of the parentheses. This is the power rule because we have a power, a 3, and also another power on the outside of it, the 2. So if we write this out, we would write the base, which is x, and then we would take our exponents and multiply them. We have a 3 times a 2. This is both numbers and letters, so our simplification will be an expression of numbers and letters. Keep the base of x, and then 3 times 2 is 6. Our simplification is x to the 6th. Now, to really understand why this happened, I will show this out real quick, and then I'm going to erase it. But x cubed raised to the second power means we write out x cubed times x cubed. Now this is just a product rule. A product rule states that when you have the same bases being multiplied, now we have 2 bases of x. These are being multiplied. The product rule states that if these 2 bases are the same being multiplied, we write the base, which is just x, and then we add the exponents. We have an exponent of 3 plus an exponent of 3, which becomes x to the 6th. It is the same answer. It is understanding that this is a simpler, cleaner way of doing the product rule, so that way you don't have to write out this thing that many times. Because if this was x cubed raised to the 13th power, you really don't want to write that out 13 different times. That's why we understand that this property is another way of doing the product rule. On our next problem, we have parentheses raised to an exponent. So we have 3 squared raised to the power of 4. Inside the parentheses, we have an exponent, and outside the parentheses, we have an exponent. This is the power rule. We have a power raised to another power. We're going to write the base. In this case, our base is 3, because that is the piece that is on the ground. The 2 and the 4 are both raised, so those are the exponents. The base is 3, and then we're going to multiply our exponents. Our 2, and then times the 4. Since these are just numbers, I will simplify it a little bit more and then simplify it fully. That means that this will become the base of 3, raised to 2 times 4 is 8. Now, because these are just numbers, we can figure out what 3 raised to the 8th power is. That means it's 3 times 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 3. That's a lot of multiplication. 3 to the 8th power, if I use a calculator, will be 6,561. Our last problem has the parentheses raised to a power. So we have h to the 5th inside the parentheses, and then we have the power of 2 on the outside of the parentheses. Since we have an exponent inside and an exponent outside, this is the power rule. We're going to take the base, which is h. We're going to write that base, which is h. And then we're going to multiply the exponents. The exponents are 5 and 2. We'll put 5 times 2. These are numbers and letters, so it will not simplify to just a value. We will write this as an expression. The base stays as h, and then 5 times 2 is 10. So our simplification is h to the 10th power. Now, you'll notice that each of these problems have only one base inside the parentheses, because that's what the power rule is taking one power and raising it to another power. However, we will also have what's called the expanded power rule. The expanded power rule states multiple powers are raised to another power. That means we're going to have more things inside the parentheses. Multiple powers are raised to another power. We do them as separate pieces. We're going to write the bases and multiply each exponent by the outside exponent. It is actually very important that everything has an exponent, including numbers and letters. So before you do any multiplication, it is important to rewrite it so that you can see every exponent inside the parentheses. The general rule here states that we have x, y inside the parentheses raised to the m power. X is a base and y is a base. The exponent of x is a 1 and the exponent of y is a 1. We would multiply 1 times m, that's where we got x to the m from, and we would do 1 times m, that's where we get y to the m power. So this is a little different because you don't see any exponents in here. We do want to make sure that we rewrite these problems so that we see the exponents on everything, numbers and letters. So this first example, A, has parentheses 2a, parentheses raised to the 3rd power. We're going to rewrite this as 2 has to have an exponent. This will be 2 raised to the 1st power. And then a has to have an exponent. We don't see an exponent, so we have to raise that to the 1st power. Then this is raised to the 3rd power. We are rewriting the inside to show that every single thing inside has an exponent. Now we can do the power rule. Each part of the power rule follows the general power rule. We're going to have the base of 2, and we're going to multiply the exponents, which is 1 and 3. We only focus on the exponent that's attached to the 2, and then the exponent on the outside. So this will be 1 times 3. We will then go to the next base of a, and we will take the exponent of that of 1 times the outside exponent, which is 3. Now if we simplify this, we have 2 raised to the 1 times 3 is 3. Then we have a raised to the 1 times 3 is 3. So we have 2 cubed, a cubed. Well, this goes back to what we saw before, that a cubed cannot simplify any further, but 2 cubed, this is just a number and a number, the base of a number and the exponent of a number. That means 2 cubed can simplify further. That means it's 2 times 2 times 2, which is 8. So our answer is 8, and then a cubed could simplify further, so it's 8a cubed. On this next example, we have parentheses x squared over y, all of that raised to the 4th power. Again, we want to rewrite this problem so that everything inside has an exponent. We have x and we have an exponent of 2, so that one already has an exponent, so that's good. Divided by, we have the base of y, and its exponent is a 1. We have to make sure we write that 1 there. So now we're going to multiply this exponent of 4 to the exponents of everything in there. I'm going to rewrite this using the expanded power rule. The numerator has a base of an x, so I write the x, and then I take my 2 exponents of 2 and I multiply it to 4. Then we have the division, and we have the denominator has a y raised to the, it already has a 1, and then we multiply it to the 4. Because these are numbers and letters, our answer will be an expression of numbers and letters. We will not simplify it any further to like 2 cubed was 8. The simplified version of this will become x raised to the 2 times 4 is 8, divided by y to the 1 times 4 is 4. And we only have one letter x and one letter y in this entire problem. That means we have simplified it completely. On this next problem, we have all of 6x cubed raised to the 2nd power. I'm going to again rewrite this. We have a 6. The exponent of the 6 is a 1. We have an x. The exponent of the x is already a 3, so that one's already good. We already have that. Close parentheses, and it's raised to the 2nd power. Now doing the power rule, I take the base of 6, I rewrite it, exponent of 1 that was already with it times that exponent on the outside of 2. Then we take the next base of x and its exponent of 3, multiply that to the 2 that's on the outside. Simplifying this becomes 6 raised to the 1 times 2 is 2, x 3 to the times 2 is 6. So we have 6 squared, x to the 6th. And going back to a, 2 cubed was 8. 6 squared can simplify further. 6 squared is 36. So our answer is 36, x to the 6th. And this last example of expanded power rule has multiple pieces as well. So we have the entire expression 2x divided by 3y squared, all of that raised to the 3rd power. So rewriting this as the numerator has a 2 raised to the 1st power. The next base is an x raised to the 1st power. The denominator has a base of 3 raised to the 1st power, and a base of y raised to the 2nd power. We already see the 2 there, so that one's good. Close parentheses, and all of that is raised to the 3rd power. Now that we've done that, we can do the expanded power rule. This will become the base of 2 raised to the 1 times 3. Then we have the base of x raised to the 1 times 3. Divided by, we have a base of 3 raised to the 1 times 3. Then we have a base of y raised to the 2 times 3, because that exponent was 2. Now as we simplify this, 2, the base of 2 is raised to the 1 times 3 is 3. The base of x is raised to the 3rd power, divided by the base of 3 is raised to the 3rd power. The base of y is raised to the 6th power. We still need to see that 2 cubed and 3 cubed have no variables with them. It means we can simplify that further. Let's go ahead and simplify that real quick. 2 cubed is 8. So we have 8x cubed in the numerator. And then 3 cubed is 3 times 3 times 3, which is 27, y to the 6th in the denominator. Now this is where you need to check if your fractions can simplify. So you'll look at the numbers and the letters. the letters are X and Y. There's only one X in the problem. That's good. There's only one Y in the problem. That's good. Now look to see if your values, your numbers, can actually simplify. 8 divided by 27. Nothing can go into both 8 and 27, so this would be our final answer. Now, I am going to make a note here to always check if fractions can simplify. And that's why I wrote it more in pencil, because I wasn't sure if that would be the final answer. But this one will be our final answer. So our final answer is 8x cubed divided by 27y to the 6th. Again, the expanded power rule is when you have multiple pieces inside the parentheses, all of that raised to an exponent larger than 1.